All right, so I already alluded to this in a previous section, talking about the domain of irrational functions. So how you determine the domain, the first step is you're basically focused on the denominator here. You can care less about the numerator. You want to focus on the denominator, and you want to first factor it if you can, and you want to see what makes the denominator equal zero. So basically we're going to set the denominator equal to zero. So we're going to take x minus 5. X minus 5 equals 0. And so what minus 5 gives you 0? X equals 5. So now, here's the thing. X cannot equal 5. If x equals 5, that makes the bottom 0, and that means it's undefined. So x can equal 5. So I got to express the domain of this. So the domain, I actually hit on this earlier. I was ahead of myself, so I apologize. So how do you do the domain? You want to do, it's basically every number but 5. So how do you express that in domain in the interval notation? You start with negative infinity, so you go forever left, and then you go to 5, but you put an open parenthesis. What this means is you do everything up until 5. It's like 4.999999 repeating. Everything up until then could be included. But when I get to 5, I'm not going to include it. I'm going to put a union, and I'm going to put an open parenthesis in 5 again, or parenthesis at 5 again. Okay, and so notice here, um, like I'm not including 5 in any spot. I'm going up until 5 and then right after 5, but not including 5. And then starting with right after 5, it will continue up until infinity. So basically what you have to do is you just do this union notation, and for the excluded values, you put these excluded values in these spots here, okay? So this would be my domain. On the next one, I'm going to see if I could find out what makes that equal to 0. I could factor this. So x squared minus 25, difference of two squares, x plus 5, x minus 5. So I'm going to set those equal to 0 using the zero product property. Subtract 5, x equals negative 5. By the way, it should be can't equals that, because these are values you can't have. So if x were to equal negative 5 or x were to equal 5, I'd have problems here, okay? So I can't have that, so I've got to express a domain that does not include those values. So I'm going to go numerical order, starting at negative infinity up until negative 5, but not including negative 5, okay? And then right after, so there's a break at negative 5, and then right after negative 5, it picks up again. And when does it stop again? Well, this time there's two excluded values, so it's going to stop until I get to 5. Okay, so like 4.9999, it's fine. But if I get to 5, I can't have 5. So I'm going to put parentheses, meaning I'm not including 5, union, and I'm going to pick up with 5 again and go to infinity. So basically, it's everything. It's not including negative 5, not including 5, but it includes everything else. Okay, so this is my answer. Now let's look at next one. And so I'm trying to think of the best way to approach this one, because you got to think what would make that equal 0. Now it's not factorable with the real numbers on the real number, but you could, I mean, theoretically, I guess I'll get into this. You could set it equal to 0 and solve it by square roots. Okay. Subtract 25, x squared equals negative 25 square root, plus or minus. What do you do when you have a negative inside the square root? You take out an I, and the square root of 25 is 5. So now, when I get my solution, I get imaginary answers. Okay? I don't get any real answers. So I'm going to make a note here. No real numbers make the bottom equal 0. The solutions are imaginary. They're not real numbers. So therefore, here's my therefore, the domain, there's no excluded values. There's no real numbers that are not included. So you would do negative infinity to positive infinity. Okay. You could look at the graphs here if you wanted to. You'll kind of, I'm going to go ahead and do this. I'm done with this, but if you want a little extension here, I can show you x squared minus 25 divided by x minus 5. So, oops, put parentheses around that. This is going to look a little different, a little weird. So you're thinking, okay, this is a line. It includes everything. Well, you're right, it's a line, but there's one little trick. I pressed trace, and my excluded value was 5. It's got a hole in it. We're going to talk about that later in this unit, okay? It's got a hole in it at 5, and so that's why 5 is not included. Let's go look at the next one. Okay, and the next one, you're going to see something. It's going to be hard. We're going to talk about graphing it later, but something called an asymptote. You will actually see the graph of the asymptote, but you'll see where it's at. So what happens on this one is that you see at -5, it's going, and then at -5, it kind of takes a break, and then it's good, 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 and then at 5, it takes a break. So there's 2 breaks in the graph at -5 and 5. Okay, we'll talk a little bit deeper about that later. Lastly, I have x plus 5. I'll kind of show you on this one, divided by x squared plus 25. If you look at this graph, there's no ever, it's hard to see it, but there's no, let me go to window, and my y is a little smaller, -2 to 2. So you see this graph is continuous. It goes on forever and ever. There's no gaps, no holes.